Hey everybody, I wanted to talk about some properties that you get when you have a circle and you draw a couple chords in the circle that cross. So I've got a picture up above me that I drew, and it's got two chords, A, C, and B, D. And there's just some properties that come from that, and I want to do actually two more proofs. I want to talk about the proofs of these. It'll be the last time we get to prove anything together. I don't think I'm going to do any more proofs. I know you're sad about that. But let's do it. So in this picture, I've got circle O. It's defined by the center point. This point E is not the center of the circle. It's just where the two chords cross. So they don't match up. That's important because this could be true for any. And then the first statement I have is that the measure of angle 1, that's this angle formed here, DEC, that measurement is 1/2 of this arc plus this arc. So if I can find the measure of this arc and the measure of this arc, add those together, divide by 2, I get that angle. So that's what the first idea is. We're going to prove that. The second one takes a little bit more work to prove. I kind of think this is a little more interesting, but I don't know, whatever. It just says if you cross these things in a circle, EA times EC is the same as EB times ED. So you can make some calculations that way. We're going to prove that too. And by proving these things, it's going to actually review a lot of stuff that we've done in geometry. That's what I like about proofs. Going through a proof really teaches you a lot about math. And so what I want to do before I actually get into writing down what the proof is I want to look at these circles in GeoGebra. GeoGebra is this really cool math calculation tool. So kind of like Desmos, but a lot more. You can do geometry in it and algebra. So we're going to go to GeoGebra. I drew the same circle, and got all the same points, and what I want to do is just start with the measurement of the angles. So I'm going to measure, I'm going to go here and measure this angle DEC, that was our angle 1, so 70.4 degrees. That is supposed to be half of arc AB and arc DC. It's half of those together. So if I multiply 70.4 times 2, I should get 140.8. Okay, so let's see if that works. Well, to find AB, to find that arc, I need to actually measure the angle AOB, because that angle is the same as the measure of the arc. So let's measure that. I don't need to draw it to measure it. I can just click on the 3 points, and it gives me a measurement. It's 40.8. Then I'm going to measure DOC, because that'll give me the arc DC. And I get 100 degrees exactly. So 100 plus 40.8 is actually twice 70.4. And it works out, and you can move these around and it'll still be true. So if I go up to move, so I can move this, and you can see the other one's staying at 40.8. So if angle E is exactly 60 degrees, 60 times 60 is 120, 40.8, sorry, 60 times 2 is 120, 40.8 plus 79.2 is 120 exactly. So no matter how you move these around, that angle property works. Well, how do we prove it? Here's what we're going to do to prove it. I'm going to actually draw a new segment from B to C. So it gives me a little triangle. So when I do that, I actually have this triangle, and this angle 1, this angle DEC, is an exterior angle to this triangle. We have a theorem called the exterior angle theorem that says this angle DEC is equal to angle B plus angle C. We're going to use that theorem. So let's go ahead and go back to the chalkboard to write that up really quick. So what we did just now was we said, okay, we're going to draw this here. And this angle 1, we'll call this angle 2, and this angle 3. How's that? And then we can write a little proof. We're just going to write some statements here. So the exterior angle theorem says measure of angle 1 equals measure of angle 2 plus measure of angle 3. So this is what we're trying to prove. This is our proof right here. So we're trying to prove this thing up here. We're going to do it down here. Measure of angle 1 equals measure of angle 2 plus measure of angle 3. And that is by the exterior angles theorem. Okay? Good stuff. Now, by the inscribed angles theorem, this is a theorem we've been using in the practice from last week. This angle, ACB, so angle 3, is half of arc AB. That was a theorem we had. We didn't prove it. We were just using it. We could. The proof for that is a big one. We can do it. But then DBC is half of arc DC. So this is half of this is half of that. We'll assume that that's true. So angle 3 is half of AB. So we can just write that down. So by the inscribed angle theorem, measure of angle 3 equals 1/2 AB, arc AB, and the measure of angle 2 is 1/2 arc DC. And those are both by the inscribed, put these theorems in parentheses, inscribed angle theorem. Okay? So now we can take all this, put it together, and we're done, basically, because I can now say that by transitivity, the measure of angle 1 is equal to, instead of writing the measure of angle 2, I can write 1/2 arc DC. And instead of writing measure of angle 3, I can write 1/2 arc AB. Now I just factor out the 1/2. I get 1/2 times the measure of DC plus the measure of AB. And then we're done. So we know that that's true about the angles, the measurements. We're going to do something similar for this, but again, let's go to GeoGebra and talk about how that works. Let's see. All right, we're back in GeoGebra. I'm going to get rid of these. What did I just do? Undo that. Get rid of these measurements because they're clogging everything up. I want to make this line a different color because it's an extra line that I drew on there. And I want to draw another one of those lines. So for this theorem, here's the goal. Draw that line. I have this triangle, right? BEC. I'm going to draw another line, another segment from A to D. Paint it red also. Oops. I want that. Okay, so those red lines are just extra lines we drew, but it makes two triangles. The cool thing about the triangles is that we can prove that those are similar triangles. How can we prove that? Well, this angle C and this angle D have to be congruent because they both intercept arc AB, and arc A, they're both 1/2 of that measure then. And if you don't believe me, we can measure them. ADB is 20.4, and then measure this angle, ACB, and it is also 20.4. It's not showing up that well. That means it's true with these two angles too. A and B have to be the same because they both intercept arc DC. So if you measure those, you'll get that. .9, and then we'll measure angle B, so D, B, C, also 46.9. So we have two pairs of angles that are congruent, plus these angles here that connect to point E have to be congruent also to their vertical angles. But we don't really need that even because to prove two triangles are similar, use that. Well, if they're similar, that means the corresponding parts are similar. If the corresponding parts are similar, then you can set up an equation, and if you can set up an equation, once you can set up that equation, then you can do what we need to do for theorem 2, which is to multiply it out. So let's do that really quick. I'm going to need to draw that other line. I'm going to draw AD. Got two triangles. We just proved that, so here's our proof. By the inscribed angles theorem, did all that get into the video? Yeah, perfect. By the inscribed angles theorem, we get that angle DB, so DBC is congruent to CAD. And for the same reason, ACB is congruent to BDA. So we can write that down here. That is congruent to that. That has to be congruent to that. We also know these are congruent if you want to write it because they're vertical angles. We don't need to say that. So just that information alone says that the two triangles are similar. So I can actually say that, therefore, these three little dots here are shorthand for therefore, if you ever need to use it in note-taking. Therefore, we can say that triangle AED is similar to triangle BEC, and then corresponding parts of similar triangles say, so that means that EA over EB is equal to, so I'm looking at, here's the EA over EB, those are corresponding because they're between those two angles, is equal to ED over EC. That's great. ED over EC, those are corresponding. We get a proportion. We can set up the proportion. What are we trying to prove? This thing up here? Well, can't I just cross multiply now? So just multiply here and here, and we get what we needed to get. EA times EC is equal to EB times ED. So those things are true. Now what I can do is all kinds of things with that information. I can solve problems and stuff, and I'm going to send you guys some examples from the book that use those theorems, solve the problems, and if you read those examples, watch this video, you're going to understand enough to be able to get those 2 questions on the essential assignment, and it'll make more sense. So I'll send you those examples, and you can let me know how it is. So have a good day, everybody. Wait, let me get out of the way so we can have all this to copy if you want it, just because you love copying proofs. All right, now, have a good day.